Let's go ahead and work on solving two-step equations. So this is section 4-5. We have looked at basically single-step equations so far. They either have had addition or subtraction or multiplication or division, but of course what happens when you throw it all together? So we'll look at some two-step and maybe some more multi-step equations in this section. And I think we should just go ahead and make some notes at first. When solving an equation in general, we are using inverse operations, and we're moving in the reverse order of PEMDAS. We're basically working backwards. So when you see addition, you work backwards and you subtract. When you see division, you work backwards and you multiply. That's the whole idea. So keep that in mind. Some other tips. Steps you could follow. 1, simplify if possible. 2, you need to go in the reverse order of operations, so you want to undo any addition or subtraction that you have. And then you want to go ahead and undo any multiplication or division. It's really important to work backwards as we solve for our variables. So that's again why we touch on the addition subtraction first and then hit the multiplication or division. So what does this look like? Well, let's look at a very basic example. So 2 times some number x plus 1 equals 9. I bet you could probably figure this out in your head. Okay, what value does x equal? And there's only one that makes this equation true. But let's go ahead and work backwards to solve this. We see that we do have multiplication. We're not going to touch that yet because we see this plus 1. So 2 times x plus 1. I'd like that to drop out. In order for it to drop out, I need to subtract 1 from each side. So I'm balancing. Make sure that you do that. And let's go ahead and write what we get. 1 minus 1 is 0, so I get 2x plus 0 equals 8. I am lining up my equal signs, so please note that here. I'm lining them up. Makes it easier to read. 2x plus 0 just gives us 2x. That's equal to 8. And now I can focus on the multiplication. To undo multiplication, we need to divide. I am going to go ahead and divide by 2, and we get our solution of x equaling 4. We can check this solution by substituting it back into the original equation, so 2 times x or 2 times 4 plus 1, does that equal 9? Well, 2 times 4 is 8, 8 plus 1 is in fact 9, so we are good to go. Let's take a look at some others. 4 equals a number n divided by 6 plus 11. The steps are going to stay the same. Don't worry that you have the 4 equals on the left-hand side instead of equals 4. It means the same exact thing. If you wanted to rewrite it, n over 6 plus 11 equals 4, that's fine. Okay, but these are in fact the same. So don't get tripped up by that. We still want to focus on the side with the variable. There's nothing to simplify. I don't have any like terms. There's nothing to distribute. So let's go ahead and undo the math. I have division and addition. I need to work backwards, so let's focus on the addition first. To undo plus 11, we are in fact going to subtract 11 from each side. Let me do the math over here on the side. 4 minus 11, I can rewrite that 4 plus negative 11, and when I set that up, I will be subtracting. I will in fact get 7, and it's going to be negative because of that negative 11. Lots of things to think through. It helps to write it down. Negative 7 equals n over 6 plus 0. You don't have to write the plus 0 in. Next, I can focus on the division. So how do you undo division? Well, you multiply. In this case, I'm going to multiply by 6 over 1 so that the 6's cancel out. So there is my balancing step. I get negative 42 equaling n. or you can rewrite it n equals negative 42. You can check it. Negative 42 divided by 6 would give you negative 7. Negative 7 plus a positive 11 would in fact give you 4, so it checks out. What about something like this? 4 minus x equals 10. It looks simple, but please be very careful. Don't tell me that x is going to equal 14 or negative 14 or something like that. We need to work through it and prove that it does not in fact equal either of those values. Let's put a 1 in front of lone variables. So what's a lone? The x. So the coefficient. Yes, I know I'm adding, or I'm not adding, but I have a 4 with the x, 4 minus x, but it's not immediately in front of the x. That 1 is the coefficient. I'm also going to rewrite the subtraction as plus negative. Again, I think this helps you to see the math. 4 minus x is the same thing as 4 plus negative 1x. But looking at it like this helps us to see what's going on here. We in fact have addition and multiplication. We need to undo the addition first. I have a positive 4. In order to have that drop out, I need to subtract 4 from each side. 4 minus 4 is 0, so I get 0 plus negative 1x equals 6. I'm writing it all out so that you can see what's happening. Plus 0, additive identity, that drops out. I get negative 1x equals 6. And now I'm down to just multiplication. And again, because I have that 1 in front of x, I can see that there is multiplication. I can go ahead and divide. Negative 1 divided by negative 1 is a positive 1, so I'm left with just 1x. 6 divided by negative 1 is negative 6. By the multiplicative identity, I get just x on the left-hand side equals negative 6. And be careful with the check. It's tricky substituting negative numbers into equations where there are minus signs. So here's the original equation. Let's substitute that negative 6 in. And the question is, does 4 minus negative 6 equal 10? And yes, in fact it does, because we have a double negative. 4 plus 6 does in fact equal 10. That works. That checks. And these are the steps I'm looking for, the balancing. Did you rewrite it? Are you subtracting 4? Are you dividing by negative 1? Do you have your solution? So please make sure that you are showing your work. What I'd like you to do now is to go ahead and try this one. 10 minus y equals negative 13. And I'm going to throw another one out here. How about negative c over 3 equals 4? So please hit pause, solve, and unpause when you're ready to check your solution. Okay, let's go through these. Plus negative 1. I'm going to subtract 10 from each side. I get negative 1y equaling negative 23. I need to add those values together. Divide by negative 1, y equals positive 23. Let's check the next equation. I can do this many different ways. I'm going to undo the division by multiplying by 3. You could multiply by negative 3 on each side. That would be fine as well. These cancel out. I get negative 1c equals 12. Divide by negative 1. C equals negative 12. When you check this one, it's a little bit different because you have negative c over 3. So negative c would actually be negative 12 over 3. Does that equal 4? It does, because of that double negative. What if I gave you something like this? 9t minus 10t equals 2.6. Again, this looks a little bit funky, but let's go back up to our notes, the top of our notes, where I said simplify first. We have like terms. Both of these terms have a t in them. So I'm going to change it to plus negative. 9t plus negative 10t is negative 1t. It makes it a lot simpler. Do not try to start dividing by 9 or by 10. Most likely you will not get the correct solution. So simplify first. Now we can balance. We can divide by -1 or multiply by -1. Either way will work. And we get t is equal to -2.6. Please try this example on your own and pause before checking your solution. So we have m minus 5m plus 3 equals 47. Alrighty, so let's go ahead and put a 1 in front of any lone variables. That's my coefficient. Plus -5m plus 3 equals 47. Okay, let's focus on this side of the equation. Do I have anything that I can simplify? Yes, I do. I have 1m plus -5m. That would give us -4m plus 3 equals 47. This is much simpler to do. I need to attack the addition first. So let me subtract that 3 from each side, so that becomes 0. And then I have -4m equals 44. I have multiplication. To undo the multiplication, I need to divide by -4. -4 divided by -4 is 1. I get 1m is equal to -11. So m equals -11. Okay. We've been working a lot with, a couple decimals here and there, but a lot of integers. Let's throw some fractions into the mix. Remember, the steps stay the same. And we've practiced working with fractions, mixed numbers, and decimals, so do not be afraid of them. In fact, go ahead and try this one on your own. Hit pause, try it. We'll go over it now. Okay, so 1/3 x minus 2/3 equals -3 1/3. You always want to ask yourself, what would you do if they weren't fractions? What if this was just 3x minus 3 equals -3? You'd focus on that minus sign. You'd rewrite it as plus negative. Okay, and you would undo any of that addition or subtraction first before attacking the multiplication. So here I have a -2/3. In order for a -2/3 to drop out, we would add 2/3 to each side. So that's exactly what I'm going to do. -2/3 plus 2/3 is 0, so I get 1/3 x plus 0 equals, and then here, let's just take a look at this math over here for a moment. It's a little bit funky. I want to make sure that I do it correctly. So I'm writing it horizontally. I have a negative plus a positive. That means I'm going to subtract. I will put the 3 1/3 on top. I have common denominators. I do in fact have to borrow, so it's nice that I set this up. 4 minus 2 is 2. Bring down the 2. Let's see, will it be positive or negative? It's going to be negative because of that -3 1/3. And there we go. I can bring that over now into my equation. I have 1/3 x equals -2 2/3. Let's go ahead and divide by 1/3 so that I can undo the multiplication of 1/3. And let's just write this out horizontally. -2 2/3 divided by 1/3. I know you can do this. We've practiced this a lot in class. When you do this math, go ahead and make an improper fraction. We get -8/3 times 3/1. It works out really nicely. I'm glad we're not trying to work with repeating decimals here. And we get -8. X equals -8. That is, in fact, the solution. We can go back and check it. Okay, so here again, just a lot of examples, a lot of practice, and this is what we're going to do in class tomorrow. I think we'll stop there for now, and I'll see you in class, and we will look at word problems and other types of examples together. Thank you. Bye.